Namaskar, my name is Manish Kumar and I welcome all of you to my channel. So in today videos we are going to talk about how can we process 100 GB of data, and this is a famous question that is asked in almost all of the interview. If you have come to know the formula, so there is no formula that I am going to discuss in this video. There will be definitely a mindset and the approach how can we go about it, but if you have come for just for the formula, so this video is not for you. You might see another video where you will just get some random formula which can calculate 100 how to process 100 GB of data, but not this video. So now without further delay, let's get started. Alright, I am here at the laptop screen and I have given the topic for today's videos where I have taken an example for 100 GB of data to process, but we will talk about 1000 GB or 1 terabyte where I was basically processing the around 0.8 to 0.9 terabyte of data, so I'll discuss that too. Okay, so the question revolves around how many executors is required and how many cores are required, what will be the driver size, what will be the driver memory. Okay. So here first understand how this Spark cluster look like, because most of the time you don't understand the cluster configurations and cluster size and you just start giving the answer which is just a random discussion that you are doing. So first understand how the Spark cluster look like in any organization. I am taking an example where I was working, this is not 16, this is 48. Okay, I was working at Geo and this was the configuration at that time in my cluster. It was total 128 GB RAM and 48 core CPU per machine. So total we had 16 machines. Out of 16, 2 was the master and 14 was the worker. Okay, so this was the configuration and this is what I have shown here also in Spark cluster. There are 2 master and 14 workers, 1 2 3 and then till 14. Okay, here if you see, one is standby Spark master. So basically at a time only one Spark master will be there. If something goes south in the Spark master, then a standby will be considered as a primary one. Okay, so this is the configurations and this is how the cluster setup looks like in our organization currently, and all of the machines details are there, or all of these machines are into a cluster, so every machine is communicating with every other machine. Okay, so this is how something it looks like. I'm not connecting all the machines here because that will look a little bit scary to see. Okay, so this is how all the machines are there and each machine knows what all other machines are available in this cluster. Now once you understand this cluster, now see how much resource is available in this cluster. So since I said I have total 14 workers and here 128 GB RAM, so total I have 1.79 GB, that is all, sorry, 1.7 TB, 1.79 TB, which I can consider 1.8 terabyte, and total 672 available core CPU were there. So this is the configurations that I have. So basically in this cluster I cannot go beyond 1.8 terabyte of hard limit RAM and 672 core CPU. Okay, now this cluster is not going to given by to the just one team. So basically there will be hundreds of processes that will be running inside this cluster. This cluster will be running 24/7, right? There are some configurations where machines can be transient or machines can be persistent. Those concepts I'm not getting into, but here if you see total configurations that is running 24/7, there are 5 teams for our example here, team 1 till team 5, and each one has a different size of applications that is running. So if you see team 1 has 3 applications. So these applications are Spark applications that is basically processing the data, and each applications are almost of same configuration. But if you see here team 2, they have a different configurations, like they have total 7 processes running and small processes are running. For team 3, if you see here 2 applications are running and both are bigger one. For team 4, it's just one application, but that application takes a lot of memory and CPU to process the data. Whereas team 5 has mix of it, like some of them are very small, some of them are medium size, right? So this kind of things you will see in a real time or in a real life whenever you work on a project. So some of the project will be processing just 1 to 2 GB of data. Some of the process will be taking 100 GB of data, terabyte of data. So each process works in a different way, different configuration will be required. And that is where this is the key concept here to decide how are we going to give 100 GB of memory. How are we going to process 100 GB of data with this configuration, like this machine, and where my application will fit, how much memory can be allocated to my project, and yeah, these are the things that we consider. So now we'll discuss things in detail while we'll go further in the video. Okay, so first understand here now. Yeah, so this solution I have seen multiple times, like I can say I have seen 100 times on LinkedIn that everyone is posting the same solution, and this is kind of a worst solution that anyone can give. But yeah, this is like a virus spreading across LinkedIn. Okay, so if you come across this kind of suggestions, just either block the person or teach them that this is not how we calculate it. Okay, so for example, they take example this way: 100 GB data is there, then total 800 partition will be there, where this coming is from is 1 GB. So basically 128 MB is the by default partition size that we take in a Parquet or any other file format. So 1 GB comes to almost 8 partition, not almost, exactly 8 partition, and then 100 GB will be 8 into 100, 800 partitions. And from here the solution go in the south direction. See, 800 partitions. So they said we would be required 800 core to process 100 GB of data. For us, it's a maximum available number of core is 672 and 1 terabyte of ROM. So they are saying this machine is not capable enough to process 1 terabyte of data. 100 GB of data according to them, right? So they need 800 core. So you can consider the kind of solution this is. Then that further down they will tell you, okay, 4 core per executor you have to give. So basically, if I have total 800 core requirement and in one machine I can give 4 cores, so I would need total 200 that kind of machine. So basically 200 executor will be required. Now memory per executor, how much memory you are going to give per executor will depends on, again they say, okay, 128 MB is default size. For processing 128 MB, you need almost 4 times RAM. So that comes 512 MB RAM per core. So one core will take 512. So you have taken total 4 core per executor here. So 128 into 4, that comes to 2 GB. So basically, no matter what you have the data volume, they will always have a 2 GB executor, which is not the case in real time. You are not going to see 2 GB executor when you have to process 100 GB of data. Generally you will see 15 GB, 20 GB, 10 GB, this kind of executor size is given in general, but they are saying I'll just give you 2 GB. And the worst part is, even if you take terabyte of data, they will always say 2 GB. Why 2 GB? Because this is not going to change, and if this cannot change, no matter what, again this will be 4 times, and then max to max they can go to 5, and that will become, so according to them 2 GB to 2.5 GB will be the executor size as always, no matter what the volume of your data is. So kind of solution you can consider how bad this can be. And this was for just 100 GB. Think of now for the 1 terabyte, that is for now I'll consider 1000 GB, right? If you have 1000 GB, according to them you need 8000 core. 8000 core means basically you need almost, I know, 15-16 times, right? 15 times of this machine. So 15 times of this machine is basically 14 workers is there. 14 into 15, it will be 150 plus 60, 210. So more than 200 machines will be required for you to calculate 1 terabyte of data, and the kind of RAM will be almost is like 30 terabyte. So 30 terabyte RAM and you'll get just 8000 core to process 1 terabyte of data. So you now can decide like how worse this solution can be, right? So you don't have to give this answer. You will get rejected upfront if you give this answer. Okay. Now see this one calculation. This is again one of the formula that people use to calculate this one. This is a reverse calculation, and here at least you will get a average value. So this calculation is not wrong. Okay. Neither calculation is wrong nor the intention is wrong. This solution will work in ideal case, but I will tell you why there is no ideal case here. Okay. So now see this calculation. This calculation says 1 core and 1 GB RAM will be reserved for worker node. Of course, if we have to send the health, like what we say, health heartbeat, we say heartbeat, right? So each server send a heartbeat to another server that okay, I am alive every 5 seconds, 2 seconds, whatever the configuration is, right? So that is where 1 GB RAM and 1 core CPU will be required to do those tasks, right? And now the remaining machines, so for our case it was 48 core CPU or 128 GB RAM. So according to them, 1 core is gone. So each machine 1 core is gone and 1 GB is gone. So total I have 650 core according to the machines that I had taken in the starting, and RAM will be almost 1.8 terabyte. So in this case, if you consider 5 core per executor on an average, then you are going to have 130 max number of executor that you can create. Yeah, that is good. And the average memory that will be required per executor will be 14 GB. So in ideal world, if you have all the applications running at the same speed, at the same volume, at the same transformation, everything is same, then you can create maximum 130 executor with each executor as 14 GB RAM. Of course, that won't be 14 GB, 10% of calculation, like 10% of the off-heap memory or overhead memory will be gone, so almost it comes to 12.5 GB. So 12.5 GB per executor and 5 core CPU. This works in real. This will not work in real life, but yeah, this is the ideal solution that anyone can give. At least this solution is acceptable. The last one was not acceptable at all. Okay. So like if you have all the teams, just now I mentioned this point, right? If you have all the teams, each has the same application. See, everyone is like copy paste, just a different data with same configuration, same kind of calculation, right? Then only this solution will work. Otherwise this will also not work, but the calculation is not wrong. Please keep that in mind, right? So this reverse calculation will also not work. Normal calculation is worst, right? So now what? That is where this thing will come, where I will talk about how to answer this question in the interview, and that is where our video start. But I had to give all the necessary points to keep in mind by not giving any absurd answer or some absurd calculation, right? So here if you see, first thing I have said, you will have to do requirement gathering. So if someone is saying process 100 GB of data, so you have to ask what kind of data is it, right? Mostly they will be like, okay, why do you need type of data? Yes, it needs, because if this is JSON or any semi-structured data like XML, this is going to eat up more memory rather than any Parquet or tabular file format, CSV, Excel. Why? Because JSON is multi-nested, and then you'll have to explode it, and then that takes a lot of memory. So type of data definitely can be considered as one of the key points deciding the number of executor or number of memory. So these are the approach. There is no right and wrong answer here. No one can tell you the formula, not even the Databricks. If it would have been so easy, Databricks would have given so many formulas to calculate, but there is no as such, because it totally depends on data. The next thing is transformation. So how many transformation is going to be there? Like 100, 1000, 200, 50, 10, simple, like wide dependency, narrow dependency. What kind of transformation is it? Of course, they are going to tell you, okay, we are making some joins, so you can consider this. Then how many transformations can I expect? 10, 50, 20? It depends, like those kind of things. Then next is, do you have a single source like 100 GB, or that is 100 GB is splitted, or above 100 GB also there are some sources that I need to be aware of, right? So those questions. And then the most important, any SLA, like you want to calculate it in how much time, like 30 minutes, 50 minutes, 1 hour, 2 hour, 5 hour, 10 hour, it depends, right? So that is where SLA is a key factor here also in deciding the number of executor and those things, right? Then the next thing you will be asking, any cluster configuration you already have a setup. Just now I told you I had a 48 core CPU and 128 GB RAM. If they are giving you the requirements, it's well and good. If they are not, if they are saying think whatever you can, so yeah, you are open to take any approach here, right? Any cluster configuration here, not approach. Now after requirement gathering, cluster configuration requirements gathering, now we will come to your approach, okay? And then you will talk about the mindset further down the line in the second or third approach. Let me show you how, okay? So I'm just doing one calculation here, there will be no other calculation. So here I'm considering that okay, while I was gathering the requirement, I come to know that okay, one table was 100 GB, another one they mentioned okay, we had another one which is 10 GB. So for now I am taking this example, this is what they gave the requirement, right? So 100 GB will be total 800 partition and 10 GB will be 80 partition that we just now calculated. That's it, there is no more further calculation I will be doing here. So now I am going to give them the approach one, that okay, I'll start with 15 GB RAM per executor, 5 core CPU per executor, and then number of executor will be 4. So total here I am taking almost 60 GB of RAM, and where this number is coming from, right? So that is where what I consider generally, if data is greater than 50 GB, so that is where you should start with the almost half of the memory. Like if I have a 50 GB, so I'll start with 25 to 30 GB of RAM, okay? So this is my, or anyone general thinking that I'll start with the half of the RAM, then the required, like half of the RAM depends on the volume. So if this is a greater than 50 GB, but you cannot say for the 1 GB or 2 GB or 5 GB data. If you have 1 GB data, so you cannot say that I will need 500 MB of RAM to process the data, because this is going to fail. Most of the time this will fail out of memory, either driver will go or executor will go. And if this is like for 1 GB, generally I consider almost 3 to 4 times. So I'll start with 4 GB RAM, okay, 2 GB RAM per executor, okay, 2 GB into 2 executor and 1 GB of RAM. That should suffice for this 4 GB of RAM. Generally I'm speaking, but it depends again the transformation. It can go beyond the number like 4 GB, it can be 7 GB, 8 GB also. But for the larger volume, I start with the half of the required volume. So that is where I am taking example of 60 GB here for almost 110 GB of source data, right? Now there is a small calculation here, but that depends on the executor memory, how my memory is going to get allocated into the executors. So you know there are 3 major memory split we have in the RAM itself or in the Spark. That first 300 MB will be gone for the reserve memory. So that is where 300 into 4, that becomes 1.2 GB, and then remaining 60% will go into the executor pool and 40% will be going into user memory, right? So these are the things that I have already talked about in one of the video, but that video is in Hindi. So that is only downside here. If you know about this, then well and good. If you don't, then you will have to first understand how memory is allocated further down the line in the Spark, like how much memory will be kept for user part, how much memory will be stored for reserve, and how much for executor. Inside executor memory pool also we have a storage and then calculation. I'm forgetting the term, but yeah, again further here also 50% is there, like 50% if you are using caching, so those memory will be allocated for this part, and then 50% here. Again here another calculation I had given that you going either for 60/40, you can change the configuration by using 70/30 or 80/20, but I don't consider going 90-10, because definitely this will give you another kind of issue, like either it can give you out of memory or it can slow down your job. So 70-30 and 75-25 or 80-20 can be tried here, but again no one knows which one will work for a better use case in this particular application, whichever you will be running. So there is a good thinking that is going behind. I'm not giving them the number, I'm giving them the approach, that this is what I'm thinking currently, right? Okay, now if I use this one 60% of that comes 36 GB. So 36 GB is the maximum amount of memory that I can get, but the minimum amount of memory I can get is 50% of it, that is 18 GB, because 18 GB will be going for caching. If I do some caching, entire 18 GB will be full for that case. If that is not the case, I can, like, this is a unified memory, so I can go beyond between 18 to 36, but I cannot go beyond 36 if 60-40 ratio is there. So that is where I have done this calculation, that minimum 18 and maximum 36. So maximum iteration will be required is 7, and minimum, if I'm lucky, I'm not using any caching, I'm not lucky at all, but yeah, if there is no caching required, so that is where I would need this 4 iteration to calculate 100 GB in just for a filter or any other thing. I'm not considering even a wide dependency transformation here. So these are the things that is going in my mind. This is what I'm explaining to the interviewer, that why I am choosing this number and what will be my next approach. So now here, if you see, this is the discussion going on. Now next is what will happen. Now I'll say, okay, this is the approach I have taken, this will be done, but the second thing what I'll do is, further I'll go and I'll see, do I have a skew data? Where will you go this? On Spark UI. On Spark UI you can see like 199 out of 200, and one task is taking a lot of time. That is where you'll come to know, okay, data is skewed. What is the minimum and maximum utilization of the executor that you have just now given, right? 4 executors were there. I'm not talking about driver, because driver is generally you can start with 10 GB, somewhere 8 to 10 GB should be more than sufficient if you are not collecting much. So driver is not much in the calculation here, just the executor is getting calculated. Okay. The next thing is which job or stages is running slower. Again, from the skew data or from the Spark UI you can come to know exactly or pinpoint exactly which job is taking becoming slower, right? And then any optimization that can be done here. And then did I meet SLA? First, like they gave you 30-minute slot and you cannot complete the processing in 30 minutes. What will be your approach? Now the second approach I'll take is I'll try to increase the memory, and I'll try to optimize the code where skewness is happening. So this is the thing I have considered in approach 2. So there is no right and wrong answer here. Again, I have increased the memory here, right? And then caching and partitioning can help or cannot help, because if you are just caching it and not utilizing multiple times, it is taking you, eating up your RAM but not using anywhere, right? So that is where I may remove the caching also. So maybe I can do one persist, right? That can also help. So this kind of thinking will go ahead. And then what I'm thinking, I'll keep the RAM same for now. I'll keep the core also same. I'll just increase the number of executors from 4. I'm going to give it 5. And again, I'll see, do I meet the SLA? If yes, then what else can be further optimized? So this is trial and error. So that is where I have talked about approach 3, where I'm saying this will be trial and error. Now based on Spark UI response, how Spark UI is showing the DAGs and those details, that is where I'll do this one. So there is no right and wrong answer. There is no formula to calculate this. This is what the mindset is when we are discussing the solution, and no one knows. Even interviewer does not know what exactly can be the answer here. And if he knows the answer, he knows for his particular application. He does not know for the entire application in this entire world. Okay. Yeah. So this was the solution, and I hope now we have a clear understanding of what needs to be answered when you have been asked this kind of question. So we have talked how many executors will be required, how many cores will be required. Driver size, I just said 8 to 10 GB should be sufficient. If you have more data, like when I was using this, or when we were calculating 0.8 to 0.9 terabyte of data, At that time I used to take 20 GB of driver, okay, and mostly 25 GB with almost 20 executor, okay. So this was the configuration and 5 core CPU. So this was the configuration we used to run, but of course every day you are not going to get 500 GB of memory or 0.8 terabyte of data. So that is where your dynamic memory allocation comes into the picture. But in production, dynamic memory allocation can be disastrous also. So we have to give the minimum number of executors that will be always required. So maybe at least I would need 10 executor always there, even if I am not working, so that I have those bandwidth to calculate the data, even if sometime I miss the SLA, but not if I'm missing the SLA every day. I'll have to give more executor, or else I'll have to increase the cluster configuration. If I have all the jobs running at the same time or something is happening, again I'll have to go to the admin, I'll have to ask. Of course you cannot get simply by just saying I need some extra RAM. They are not going to provision you. They will say, okay, give me the requirements, give me the exact issue, why are you asking for this, and all those things happens in the real time. Like you'll have to justify each and every RAM that would be required, or each and every machine that would be required, right? And driver memory, driver size, the same thing. Driver size and memory, I think I just wrote by mistake. So yeah, these are the things that you will have to discuss. There is no formula at the last time I'm saying, and I think we are done with the video. So that's it for the today's videos. We will meet in the next video. Till then, bye bye.